A motorcycle has to move with a constant speed on an overbridge, which is in the form of circular arc of radius r and has total length L. Suppose the motorcycle starts from the highest point at this point. What can its maximum velocity be for which the contact with the road is not broken at the highest point? Part B. If the motorcycle goes at a speed 1 upon root 2 times the maximum found in part A, where will it lose the contact with the road? What maximum uniform speed can it maintain on the bridge if it does not lose contact anywhere on the bridge? So there are three situations. Let's discuss one by one. The length of arc is L, radius is R. So we can say arc upon radius equal to angle. So 2 alpha equal to L upon R. Now, at highest point, weight will be in downward direction and the centrifugal force will be in upward direction. The two must be equal. So mg must be equal to mv square upon r, from where we get v equal to root rg. Mm will cancel out and then we will cross multiply. So v equal to square root r. So this is first case. Now, if the motorcycle goes at a speed 1 upon root 2 times the maximum found in part here. So now, new speed is v dash, which is 1 upon root 2 times this value. That is rg. So we have to find out the point where it loses the contact. So suppose situation is, suppose this is the point where motorcycle loses the contact. So its weight will be in this direction, like this. And here, this angle will be alpha. This angle will also be alpha. So, sorry, it can't be alpha because total angle is up to here. This is alpha. So let's take it as theta. So that will be easy. So here, this angle is theta. So this angle is also theta. Now, at this point, we suppose that motorcycle loses the contact. So mg will be in this direction. This angle is theta. Mg cos theta will be toward the center. So mg cos theta must provide centrifugal force. So we can say mg cos theta must be equal to mv square upon r. Mm will cancel out. Rg cos theta must be equal to v square, but this time we have to take this value of v. So this should be v dash square, and v dash equal to rg square root divided by root 2. So if we square it, so it will become rg divided by 2. Now rg will cancel out, and we will get cos theta equals 1 by 2, or theta equal to pi by 3. This is in radian. Now, distance covered from midpoint. If we want to find out this distance where the motorcycle loses the contact, so suppose this is x. So x upon r is equal to theta. So x we have to find out r theta, and theta is pi by 2. So this is our answer. Let's go to third part. Third part says what maximum uniform speed can it maintain on the bridge if it does not lose contact anywhere on the bridge. So it will reach till this point. So let's consider the situation. Now, we can say that motorcycle reaches up to this point. So weight mg will act in this direction. This angle will be alpha. This angle will be alpha because these two lines are parallel. Now, we know that 2 alpha arc upon radius L upon R equal to total angle by 2 alpha. So we can find alpha from here. Alpha will be equal to L upon 2R. At this situation, we can say mg cos alpha must be equal to mv square upon R. So mg cos alpha equal to mv square upon R. Now mm will cancel out, and our purpose is to get velocity. So v will be equal to square root rg cos alpha, where alpha is this much. So we can put this value here. So rg cos of L by 2r, and that is our answer. Now, let's go to next question. Next question says, a car goes on a horizontal circular road of radius r, the speed increasing at a constant rate dv upon dt equal to a. The friction coefficient between the road and the tire is mu. Find the speed at which the car will skid. So, situation we can show by drawing the diagram. This is circular path. And here we can locate the center. Now, centripetal force. So here, let's find out centripetal acceleration. So it is also a radial acceleration. So AR will be V square upon R. And we are given here tangential acceleration dV upon dt as A, which is A tangential. Now, total acceleration, the two will be perpendicular to each other. So in this direction, it will be AC or AR, and in this direction, it will be AT, and angle will be 90 degree between the two. So we can say A total will be the square root of AR square, that is V square upon R whole square, plus A square. So this will become A square plus V power 4 divided by R square. Here, we can do one thing. In place of A, if we write alpha, so it will be clear, means we can easily distinguish. So A total, we can write as alpha square plus V power 4 divided by R square. Now, frictional force mu n must be equal to m times A total, and n equal to mg because road is leveled. So we can say mu times mg is equal to m times A total, and A total we have found here as alpha square plus V power 4 divided by R square. M will cancel out. And here our purpose is to get V. So we have to square it. So it will become mu square G square equal to alpha square plus V power 4 divided by R square. Now let's simplify it further. So we can multiply each term by R square. So mu square G square R square equal to alpha square R square plus V power 4. Sorry, V power 4. Now let's simplify it further. So it will become v power 4 equals mu square g square r square minus alpha square r power 2 or r square. We can take out r square. So mu square g square minus alpha square, or v equal to r square mu square g square minus alpha square whole power 1 by 4. And that is our answer. Thank you for watching.